I already discussed about the short circuit conductance method to calculate the voltage gain in a separate video. So in this video, I'll try to use this method to calculate the voltage gain for a common drain amplifier. So this is basically our common drain amplifier where we are applying a signal at the gate and we are getting that output from the source terminal. And of course, we need to bias the transistor with a current source here, or also you can bias it using a voltage source as well. So here I'm considering an ideal current source I0. Now, as I said, I will apply a short circuit GM method to calculate the voltage gain. So firstly, we need to calculate the short circuit current from the output. For that, see, this is the output, and in small signal, this is completely open. So we can see we have basically one GM times VI current that is there, and along with that R0. And from this node, we can calculate what exactly the ISC. So as you can see, this R0 is connected here to the ground. Here also it is grounded. So there is no use of this R0. So we can directly see that VGS is basically VI in small signal. So we can calculate that short circuit current is basically this GM times VI. Correct. And so this capital GM short circuit transconductor is basically your same as that transistor GM. And note that this GM actually depends on the current I0. Correct. Now we can calculate the R out directly. So this is basically we need to apply a voltage source Vx and you need to see what exactly the current Ix. So again, the same thing. We have this current dependent current GM times VGS. Now for R out calculation, this input voltage is 0. Correct. So what exactly the VGS? VGS is basically your minus Vx. Okay. So this is 0. This is Vx. So VGS is minus Vx. So you can see this is the current GM Vx, or you can also write it as, you can reverse the direction of current and you can directly write the KCL from here. So you can use this direction for the current, and you can use the positive sign of the Vx. Then we have R0. So now you can write the KCL over here. So Ix is basically this current. Ix is basically this current GM times Vx, and the current through the R0, that is basically Vx by R0. So this is Vx and this is grounded. So Vx by R0. Okay. So from here you can calculate the Vx by Rs. That is basically your GM plus G0. Okay. So 1 by R0 is basically G0. Okay. So R out is basically 1 over GM plus G0. All right. Now the formula is pretty simple. You can just need to multiply this capital GM and R out. Then you will get the expression for the voltage gain. That is basically GM. So this GM by this GM plus G0. Okay. Now if we consider that the R0 is very high, that's let's say in most of the cases that is actually the case. So in that case, you can approximate this expression as 1, because if R0 is very high, in that case you can ignore the G0. So GM by GM is basically approximately equals to 1. All right.